Hey guys, BuildZoid here, and welcome to HWBot Score Roundup number 10. It's been quite a week in terms of scores posted to HWBot. We've got a lot of big top scores for sort of kind of more obscure hardware, I'd argue. So yeah, let's get right into it, starting off with Splave's GPU Pi for CPU 1 billion score. So this is a CPU benchmark that calculates 1 billion digits of the number pi. It's multi-threaded, and this is the quad-core category. And yeah, Splave took first place using the Ryzen 3 5300G at 5.425 gigahertz. On liquid nitrogen, running on a ASRock X570 OC formula. Splave is supported by ASRock, so he basically only uses ASRock motherboards. Is that dual rank? No, single rank for the memory. Oh right, because APUs can actually run high memory speeds, so you don't need to run dual rank for that. But yeah, so 4600, 1414, 48. I still don't know why Splave has his TRAS set so loose. Because the thing is, if he sets the TRC to 30, I guess the board pulls the TRAS down for him. Because the thing, theoretically, your TRC shouldn't be, you shouldn't be able to set your TRC below TRAS plus TRP. So I'm pretty sure what's happening there is that his TRAS is being set to 21. Yeah, which would actually make a lot of sense. His actual TRAS is 21. This is 14, 14, 14, 21, because otherwise that 35, either the 35 or the 48 is getting overwritten. Because the memory controller shouldn't let you to have this combination of timings, so one of those is not being accepted. And I'd say it's probably the TRAS that's getting pulled down to 21, because that works just fine. TRAS of 21 does. Anyway, 5.425 gigahertz on the CPU, 1.76 volts, because well, we are on liquid nitrogen. I wonder how cold he's running it. Oh, he doesn't mention. Yeah, benchmark finished in 2 minutes and 4 seconds. Oh, also the Infinity Fabric's doing 2300 megahertz, but it's an APU. They just kind of do that because they're monolithic, whereas your regular Ryzen chips are obviously, the Infinity Fabric has to go through the substrate, and that's not great for high-speed signals, like the Infinity Fabric. So, yeah, just a very solid score out of the 5300G. I mean, we already looked at Splave, Splave already posted a really high-ranking 5300G score last week, except that was pre-testing on water cooling, and so yeah, here we are. He finally ran it on liquid nitrogen, and first place. Beating Yoss's score. I actually wonder what Yoss was running. Yoss was actually running a higher CPU frequency, and much worse TRC. Yeah. TRC is, important for performance. I wouldn't be surprised if that was most of it. Because other than that... Oh, they also have some differences in how they've configured GPU Pi. So this is one of the nicer benchmarks where you do have a few different options for tuning how the benchmark runs. Which, you can sort of make it... the idea behind that is, you can optimize it for specific CPUs. Which just makes it more interesting as a benchmark that if you're running it. I guess as a standardized performance measurement system, it sort of starts failing. But it's more fun to overclock, to work on benchmarks where it's you can tweak how the benchmark runs to more match how the CPU architecture behaves. So there are certain, so basically the settings you're fiddling with change how, say, the cache and the memory is getting loaded by the benchmark. Yeah. So, yeah, solid score from Splave. I don't know that we can say that he has some kind of incredible efficiency here in terms of, getting this score with these kinds of settings, because, Yoss's memory settings here look like he just... I would not be surprised if his sub-timings were on auto, considering that his TRC evidently is. TRC 1, a TRC of 114 is just terrible. You should not be running that TRC that loose. But anyway, yeah, solid, literally fastest quad-core to ever run this benchmark from Splave here. So, congratulations to him on that score, and let's move on to the next score. which this isn't obscure hardware. This is an RTX, the dual RTX 3090s in, wait, is it dual or single? Single. Okay, so Biso's back to running just one 3090 instead of two of them. I wonder if he'll also run. Actually, does Unigine Superposition even support dual 3090s? I'm not sure. And anyway, Biso, taking the first place in Unigine Superposition 1080p Extreme with an RTX 3090 Kingpin edition on liquid nitrogen. He's very good at benching 3090s. Yeah, so it comes as no surprise that he's getting first place in this again. We have the Noctua fan sandwich for cooling the VRM. CPU is a 10900K at 5.4 gigahertz with just 10 threads and without hyperthreading enabled, because if you don't need the extra threads, the hyperthreading only hurts your single-threaded performance. So if you're not running a multi-threaded test, it really isn't worth keeping it turned on. Card absolutely flying at 2.83, 2835 megahertz on the core, 1481 megahertz on the memory. So that's like a really high memory clock for a 3090. Like 3090s on LN2, the memory actually doesn't like getting cold. So a big problem with 3090s is that when you take them on liquid nitrogen, the memory just gets very upset about it. We can't. I'm assuming he has to be running a heater on the back of the GPU, because you just can't run them properly on liquid nitrogen otherwise. I wonder if we'll see if we can see that in OGS's system. Oh no, we can't see the back of the card, but yeah, it's a very common thing on 3090s to actually have some kind of system for heating the back of the card, because if you don't heat the back of if you don't heat up the memory chips, they just lose all stability when they're cold, and it makes running memory clocks like that absolutely impossible. So yeah, 3090s are very, and then of course you just have the card pulls a stupid amount of power, and it loves to, lose thermal paste contact. Then there's also the fact that from the factory, the 3090 chip actually comes very uneven. So I think all of the top scores are actually done with 3090s. Like all the top 3 3090 scores, maybe even top 5 3090 scores, are generally done on cards that had their die lapped so that it was actually flat, because otherwise, the unevenness of the core means that you just start getting hotspots when you're pushing really, really, really high amounts of power. I mean, technically, you're still getting hotspots if you're on air cooling or water cooling, but they're less significant because you're not shoving, potentially 1,000 watts through the card or more. That's kind of the thing. Anyway, I mean, at this point, it's kind of, I think Biso's been in. He's been in several roundups, so it's kind of just routine. Yes, Biso is back with a top RTX 3090 score on his 3090 Kingpin edition. So congratulations to him on taking Unigine Superposition 1080p Extreme single card. I think he already had this record, so I'm not sure if he's improving on it, or maybe this was one of the ones he missed. But yeah, congratulations to him on the top score in this benchmark, and let's move on to the next score, which is Senz's Cinebench R20 16-core top score using a Ryzen 9 5950X at 6 gigahertz on a Crosshair 8 Dark Hero motherboard. And yeah, this is of course on liquid nitrogen. Running single rank memory at 2066 1414. That is really, though his infinite, it's Cinebench. It barely, Cinebench on Ryzen just barely cares about your memory, because most of the workload seems to fit into the L3 cache, so the memory is just kind of there to look pretty. 5950X at 6 gigahertz, that's a lot of core voltage. So yeah, he must have had that really, evidently the IHS came pretty flat from the factory, because that looks like a good thermal paste spread right there. It's nice and even, and there's very little thermal paste, which, that's what you're aiming for. Having, with thermal paste, it's there to fill in the really, really, really small imperfections in the IHS. If you have great big, if you have a lot of thermal paste between the CPU and between the IHS and the LN2 pot, then it's like that's actually bad, right? So what you want to see is you want to see all of the thermal paste squeezed out to the edges, so that there's the absolute bare minimum between the actual CPU and the LN2 pot, so that you get as much metal to metal contact as possible. You don't really want like all of your heat having to go through the thermal paste. The thermal paste is there to fill the gaps where metal to metal contact is not possible. So yeah, very like great looking thermal paste application right there. And then here we have the actual setup when it's running. So yeah, no VRM heatsink, because the thing is with a lot of, well, when you're running full platforms like this, especially with motherboards that actually have really powerful VRMs. Now, there's some motherboards where if you did this, the VRM would die before you finish the benchmark. But this is a Crosshair 8 Dark Hero, so yeah, you don't need VRM heatsinks for running Cinebench R20, even if the chip is doing 6 gigahertz. Like, this benchmark just doesn't take long enough to really max out the VRM on or more like cause any issues for the VRM on the Crosshair 8 Dark Hero before the benchmark manages to finish. And yeah, 6 gigahertz, like that is, for Ryzen CPUs, doing 6 gigahertz is incredibly hard. Right, like there's literally just one other chip, one other 5950X that has ever run Cinebench R20 at 6 gigahertz, and that's Splave's. So yeah, great result from Sens here in Cinebench R20 for 16-core CPUs. Congratulations to him on that, and let's move on to the next score, which is Der Burner's score in Cinebench R20 on 8-core CPUs. Third place with the 11900K at 6.563 gigahertz. Yeah, running on a Gigabyte Z590 Tachyon. Yeah, Z590 Tachyon. And Der Burner actually makes LN2 pots, and currently there seem to be some of the best LN2 pots. I believe this right here is from a test session for a new LN2 pot design, or like they were testing something during this session. The priority wasn't just getting top scores, but you know that certainly didn't stop him from getting a top score here. As that is a third place in 8-core Cinebench R20, which very competitive ranking, right? Like if we look at it, like most of the lower core count Cinebenches are extremely competitive because it's just such a simple benchmark to run. So yeah. Anyway. 4666 on the memory, and like the thing is that's almost daily settings. It's Cinebench. It doesn't care about RAM. It cares about, on Intel chips, it cares about RAM a bit more, but it's still like it's not quite to the level of like Ryzen chips where like memory settings don't, like in some situations you can literally go from like JDEC to like super aggressive memory settings, and it won't make a difference for Cinebench. And then like Intel, it's not quite that bad, where like the CPU has so much cache that it just doesn't care about the memory settings. But yeah, it's certainly sort of getting there. So that's why we're looking at memory settings. Like if you had a good strong kit of Samsung VDI, you could daily that. Like that would be actually something you could daily, settings like that. So yeah. Just a very, solid Cinebench score out of that 11900K. And congratulations to Burner on the top score. I mean, yeah, on the third place. And let's move on to the next score, which is Royal Maroc's Unigen Superposition 1080p Extreme triple GPU top score. And I love multi-GPU setups. I'm very upset that we don't have Crossfire support anymore on 6900 XTs. Or really any other cards, right? I know, like, here's the thing. I actually ran multiple Crossfire setups in my daily system back when Crossfire was supported. And yeah, it didn't work. Like, there was basically nothing that would actually run properly with Crossfire enabled in my experience. But for benchmarks, it was cool. Like the worst part was like even even Dirt Rally, which was like a AMD supported title, like that would crash if I had Crossfire enabled. Like it just wouldn't start a lot of the time, which was just like that. Yeah, so like I can totally understand why Crossfire is not a thing anymore, but I do wish it was like still supported at least for benchmarks. Even as pointless as it would be, it's just like, well, it's cool to have, you know, setups like this with triple GPUs. So yeah, three R9 290Xs doing 1240 core and 1550 on the memory. I believe these are Elpida cards because I think he's been in a Royal Maroc's been in a past hardware bot score roundup with these cards. Yeah, he's been in a roundup before with these cards, and if I remember, yeah, they're on Elpida, which is really unfortunate. That's actually not a bad memory clock for Elpida VRAM on 290Xs. Like that's actually very good. That's basically the limit of Elpida memory on a 290X. Like, if you can do 1550 on Elpida, that's a good thing. Because, man, Elpida GDDR5 is trash. Like, it's so bad. Like, there are cards out there that won't go over, like, 1400 on Elpida memory. So, 1550 is really, really good. Considering the really terrible memory that those cards have. Or at least one of them has. I don't know if all three of them are Elpida, but they might be. Which would be pretty unfortunate. But yeah, still 7960X on water cooling. All three of the cards on water cooling, which is a necessity. You're not really like you need an exceptional like you'd need a crazy high silicon quality to be pushing over 1200 core on, you know, air cooling. How many cards that and then if you were trying to do it on 3 cards, you'd have to get lucky really lucky 3 times in a row, right? So that makes that really difficult. And yeah, I wonder how much power this setup was pulling. He's on a 1300 watt Seasonic power supply. I'm surprised he didn't manage to get that shut down. I guess he's not pushing that much voltage into them. Because I've managed to shut down a 1600 watt power supply with like triple GPUs on HEDT. Then again, superposition might not be that heavy on the CPU power consumption, so that might be helping. Yeah, all around very solid triple GPU score. And apparently the biggest problem with Unigen superposition here is just getting Crossfire to function, which is like, well, I mean, it's Crossfire. Like, when is it not a problem to get it to run properly? Well, that's... Firestrike's pretty easy. At least depending on which driver version you're on, like, it's pretty easy to get it to work. But, yeah, Crossfire not working has to be, like, that's why it's not a thing anymore. It's just, it was too damn unreliable. But anyway, really awesome score from Royal Maroc here. Like, those 290Xs are... like, yeah, you're not really going to see a triple 290X setup going much faster than this. Right? So, yeah, like, just a very, very solid triple GPU setup right here. And I love big multi-GPU setups, so of course this score gets into the roundup. Anyway, let's take a look at the next score, which is Dark Gregor's PCMark 10 Express on a 6-core CPU. So that's a Core i5-11600K on a Maximus 13 Apex motherboard, doing just under 6.4 gigahertz with an overclocked 7970. This is really interesting to me about PCMark 10. Is just like, this is technically a CPU benchmark, or at least it's categorized as a... Oh wait, no, it's a 7970 Lightning. It just comes at 1150 on the core. Yeah, it just comes with that. It's the Boost Edition, not the Black Edition. It's the Boost Edition. But yeah, those just come at 1150. So I was like the thing is, when I was looking at these scores earlier, I was like, oh whoa, another overclocked 7970 for another AMD card that got overclocked for PCMark. But no, this is literally like the BIOS that card comes with, just is at those really high clocks. But yeah, I don't know much about PCMark 10, but evidently it loves low latency memory settings and massive CPU clocks. So that's what we're looking at here, and also Optane SSDs, as that is a Optane 900p SSD. Because the thing is, this is supposed to be like an office productivity benchmark, so of course it's going to do some file copying stuff and. Well, you don't really get faster than Optane, as far as I know, and I don't really pay attention to high-speed storage. It just doesn't really interest me very much. But yeah, so very solid score from Dark Gregor here in PCMark 10, second place for 6-core CPUs. So congratulations to him on that, and actually really close to the top of the overall world record ranking. Yeah. Really, really close, right? Like, there's the 11900K doing just over 10,000 points, and then we've got 11600Ks doing, 300 points less. So this is a weird benchmark. I guess a lot of it just comes down to the SSD you're running. I wonder if you could put, like, a crazy multi-Optane SSD RAID setup in, like, if... Yeah, like, could you not just RAID a bunch of Optane SSDs and then run them on this, like, run them through PCMark 10? I'd assume Optane SSDs support RAID, right? Like, yeah. Anyway, yeah, congratulations to Dark Gregor on the second place in the CPU category, and actually, like, third place in the world for this benchmark, which, arguably more impressive. So, yeah, very, very solid score. And let's move on to the next score, which is QuickMew. He's been, like, digging up or getting his hands on a lot of server hardware recently. Because we already had him in, I think, the last roundup. He had a bunch of, like, Xeons, I think, for 72 core. Like, some awkward core count that's like, wait, you can do that? And apparently you could. So he was at the top of that ranking. Now he's gotten his hands on a pair of Xeon Gold 6248R CPUs. These run at 4 gigahertz? Or do they just... Oh, they just boost to 4 gigahertz for... Oh, right, yeah, because this would be submitted through Benchmate, so it would record the boost frequency. So these boost up to 4 gigahertz. I can't imagine they were actually sustaining 4 gigahertz because that's GPU Pi and that is a multi-threaded, CPU benchmark. It's pretty power hungry. So actually, I'm not sure. Well, it only lasted 37 seconds. So maybe these were at full boost. I have no idea. I don't pay that much attention to server hardware because you really can't overclock it. And yeah, this is like JDEC memory settings, literally stock CPU settings. Interesting, like the cooling setup for servers is kind of interesting. If you're wondering about wondering what's up with the like towel type things over here, this is to force more air through the actual CPU fin stack, like CPU heatsinks, because these are the CPU heatsinks, and if you don't have those towels just jammed in above them, a lot of the air, instead of getting pushed into the actual fin stack, it would just go over the fin stack, which doesn't really do you any favors in terms of cooling. So, yeah, that's what's going on with those. The idea being in an actual, like, normal server configuration, I guess you wouldn't, like, the server doesn't, I can't imagine that the server comes with those towels. So I would assume the reason why they leave that air gap above the CPU heatsink is to supply fresh air to like other things in the rack. But in this scenario, like, this is a CPU benchmark, so the priority is CPU cooling and everything else. Like, there is nothing else, right? Like, there's like the rest of the system's empty, so it really doesn't matter if you reduce the overall amount of airflow in order to just get more air into the cooling system for the CPUs. So... yeah, interesting score from QuickMew here in a rather exotic CPU category. And so congratulations to him on taking first place in the 48-core GPU Pi for CPU 1 billion rankings. And let's take a look at the next score, which is Dr. Tesla's Y-Cruncher Pi 1 billion score, third place using a 14-core CPU. This is done with a 7940X at 4.342 gigahertz. And you might be like, isn't that really, really slow? Well, you see, the thing is, Y-Cruncher uses AVX 512. So this chip is on chilled water cooling, and it was still hitting 90 degrees load, which to me is actually, you could have pushed the frequency higher. Like 90C, if it's not hitting the thermal throttle, you can raise the frequency. Also, Benchmade has apparently managed to record a 475 watt CPU power draw. Yep, that sounds about right for Y-Cruncher. It, you know, on a 14 core 14 core X299 CPU. Minimum CPU temperature is 17 degrees, so evidently, yeah, like it's on chilled water cooling, though at the same time the idle power draw on a lot of these X299 chips is actually quite high. So the water, like, if I had to guess, that water chiller is probably running around 15 degrees or something. Yeah, something like that. So not super cold. Unless the temperature recording is from like the start of the benchmark, in which case I have no idea what temperature it's running at. It's a shame we don't have a system picture, or at least you know, an indication of how cold this chilled water cooling system is going. But yeah, the thing is, Y-Cruncher is, like, this is basically a stress test. This is right up there with, like, Linpack in terms of how it just abuses the CPU. Though this is very memory-starved compared to Like, Linpack is also pretty memory-starved, but this is arguably more so. And so this is actually not so much about CPU frequency as it is about memory settings. And yeah, so Dr. Tesla here is running a X299 Gaming M7 motherboard. You don't really see a lot of people running MSI X299 motherboards on HWBot. It's usually like you see a lot of Rampage 6 Apexes. You see Rampage 6 Extreme, like, well, Rampage 6 boards, basically. You see X299 OC formulas and X299 darks. MSI is really underrepresented in the X299 overclocking arena. So it's kind of interesting. Like, it's kind of neat to see an MSI board for once in a top X299 score. Running 36, what is that? No, that's 3760 on the memory. 1428. I think you could probably push the frequency higher. Well, I'm not sure if, like, the motherboard, how it is on, like, the X299 is interesting. Like, the max memory frequency you can run on it is really dependent on what motherboard you have. And, like, basically, if you have some motherboards will do, like, 4,000 plus. A lot of other motherboards will get stuck somewhere in the 3,800 range. I'm not sure how it works out for all motherboards, but basically, yeah, that's kind of the frequency ranges that you're working with. Like, most motherboards, you're going to be looking at settings that look something like this. And then there's some motherboards, say the X299 Dark, for example, where you can go up to 4,000 and higher if your memory controller is good enough. Then again, I'm not sure how much, like, maybe Dr. Tesla is just not shoving enough uncore offset into the CPU, because the thing is with these chips, you just shove a ton of system agent voltage into, well, it's not system agent voltage. There's basically like a different, so compared to mainstream CPUs, you have a system agent rail, which doesn't do anything. You have a IO rail, which at ambient doesn't do anything. And then you have a what's called uncore offset voltage rail, which is actually generated, I believe, by the fully integrated voltage regulator, whereas the system agent and the I/O rail are actually generated by the motherboard, which is kind of interesting. That, you know, those are separate from the integrated voltage regulator and done by the motherboard. I think that's mostly in order for X299 to have support for Skylake CPUs, like the Kaby Lake X chips, right? Like the 7740X, 7640X, because those don't have integrated voltage regulators. But anyway, the thing is, the trick to running high memory frequency on most of these chips is to just run really, really high uncore offset voltages. The more uncore offset you give it up to a point, there's a point where it rolls over, and if you keep keep raising the voltage, your max memory frequency actually starts coming down. But until that point, you just keep raising it, and the max frequency that you can run goes up. And for something like Wittix, that's basically the best thing you can do, because this thing is super memory bottlenecked on 14-core CPUs. Like, it's ridiculously memory bottlenecked. So, you know, it's so memory bottleneck that you can actually end up trading core speed for memory speed and still end up with like higher scores. And a lot of the time you will end up trading core speed for memory speed, because as you reduce the memory bottleneck in this benchmark, the power consumption keeps going up. So if you have a really memory bottlenecked, if you're running really terrible memory settings, you can run like 4.5 gigahertz for Wittix. It's just fine. And then if you actually have good memory settings, you can't run high core frequencies, because the chip just suddenly starts pulling a ton of power, because basically instead of sitting there, you know, waiting for work to show up from the memory, it has work to do. And so the power consumption just goes through the roof. So yeah, I really like this benchmark. This is an interesting one. It's like, cause yeah, like there's not really anything like it where it's like, you know, super insanely hot. Also very stability. Like this thing will complain about stability, quite a lot. Like this is one of those benchmarks that like this is borderline stress test. Like the only thing that separates this from an actual stress test is the fact that it finishes in like 18 seconds. But yeah, like a lot of settings that would pass a bunch of other benchmarks won't pass this. So I'm a big fan of Wittix as like horrible, like as horrible, like it's as close as we're gonna get to running Prime 95 on HWBot competitively. Or it's actually more like LNPAC, because Prime 95, depending on what settings you're running, is not going to be memory starved, but this is a lot like LNPAC, where it's like, yeah, your max CPU frequency goes down as your memory settings get better, because the benchmark is just so insanely memory bottlenecked. But at the same time, you know, it does improve in terms of the scores with CPU frequency. It's just that there's that huge memory component to it. So yeah, cool benchmark. And also just great score from Dr. Tesla here, right? Getting third place. And actually, I wonder if we might see some of the, like, yeah, see, this right here. This is exactly what I'm talking about. If your memory settings are trash, you can run really high frequencies in this benchmark. Let's see what this... I mean, those aren't even that bad, so I don't know what he's doing that it's running so slow. I am very... How are you even... How... Like, there is some optimizations you can do. Again, this is one of those benchmarks that lets you fiddle with, like, you know, how it actually interacts with the CPU, so that you can optimize it a bit more for, like, NUMA and that kind of thing. But, how the hell is his score so bad? Either way, if you can run a high frequency in Wittix, it's because you're bottlenecked by something. That's my personal experience, is like, if Wittix seems to be running cool and you can run a high frequency in it, it's because your memory settings aren't good enough. So yeah, and then we have like, yeah, this is more in line, and then yes, yeah. So this is the thing, is just like, whoever has the high, like you can have a really high frequency and a terrible score because you're just not getting, like, the data's just not getting to the CPU. So the CPU is just sort of sitting there twiddling its thumbs going like, you know, it'd be really cool if I had work to do. Except I'm waiting on my memory controller for that. So this is sort of... Yeah, okay, so this is actually a good example of that, because this is running 3400 on the memory at CL19. So this is like, yeah, this is actual terrible memory settings. And, you know, 4.4 gigahertz. Admittedly, still at pretty low voltage, but yeah, like that's the thing with Wittix, is just like, this is like, it is a memory. It, like, the thing is, like, once you get the memory settings moving, you do still need to, like, more CPU clock obviously helps, right? The record is Splave's 4.7 gigahertz CPU here, but the thing is, it is not just about like this is why I like this benchmark. It's just like you can the memory settings like matter a lot, and at the same time it's super heavy. It's not Super Pi. It's kind of like Super Pi, but it doesn't have a bunch of weird like OS things you can do to it, at least that I'm aware of. Yeah, and then here we have, this is actually good memory settings, so I don't know oh, he disabled hyperthreading. Oh well. Actually, the interesting thing is for some AVX workloads, that's actually a good idea, but apparently not for this one. Because the thing is, because of how insanely memory heavy something like Y Cruncher can be, if you have hyperthreading enabled, you can actually end up in a situation where two threads running on the same core will be conflicting with each other's memory access, and so it slows them down. But apparently that's not going on here because this is 14 cores, 14 threads, and actually really solid memory settings, but not really doing that great in terms of being, in terms of the overall result. So yeah, cool benchmark. I wish more people ran it because it's an actual, like, this is the most interesting multi-core benchmark there is. The only unfortunate thing is there's some rankings where like if you have a 6-core dual channel CPU, you're just gonna lose to a 6-core quad channel CPU. There's not really much you can do about it. Because yeah, like especially since the X299 HEDT chips have AVX 512 acceleration, so yeah, that's kind of like this is unfortunately basically an X299 benchmark only, which is a bit unfortunate because it's also really cool. Like it's a really cool benchmark in terms of just how it behaves, in my opinion. But yeah, congratulations to Dr. Tesla on like figuring out how to run Y Cruncher properly. Because that is, third place, 4.34 gigahertz. I think he could still work on his memory settings. Like there should still be room in that. Like TRFC could probably go lower. Cast latency TRFC could probably go lower. I'm not sure about the rest. It would be interesting to see the subtimings. Also, well, I'm not sure how the MSI motherboards play with dual rank, but like dual rank is a potential way to get more performance in Y Cruncher, assuming that you don't lose too much clock speed to it, because that's obviously like that's always the trade-off with like if you go from single rank to dual rank, you get more performance per clock, but on some motherboards you lose like way too much frequency to actually justify the increase in performance per clock. So yeah, there's a balancing act that you sort of have to do with how many ranks you're running for it. But single rank will generally do quite well in Y Cruncher because unfortunately it's not until very recently that motherboard manufacturers have actually started paying attention to dual rank memory setups in terms of like tuning the BIOSes for running them properly. But yeah, so congratulations to Dr. Tesla on that 7940X third, like 14, well, on that Y Cruncher score. And let's move on to the next score, which is Bavore's Port Royal score with two RTX 3090s on chilled water cooling. And this got in because that's, yeah, ice bucket water cooling. Which is just cool to see, right? Like it's not the usual like, oh, there's a phase change chiller or something like. It's cool. It's just cool to see, different methods of achieving sub-ambient cooling. Some of them being very sketchy, like this right here. So, yeah, just radiator in an ice bath with a pump for providing water flow. Because otherwise, like the thing is, just yeah, hot water rises, but very slowly. So that's why you would want to pump in there to, keep up the water flow rate. And then third place in the, what is it, 3D Mark Port Royal rankings with this chilled setup, and also running a 5950X, which is a I think this is probably the only 5950X in the higher end of the Port Royal rankings, because most people run this on a 10900K. I'm not sure if there's necessarily any benefits to doing that or downsides, because technically 3090s do support PCIe 4.0, but that doesn't inherently mean that, say, Port Royal is going to be, moving so much data across the PCIe that it actually needs PCIe 4.0. which is why, like, well, this is on a 3.0 platform. The world record is, I think, on a 10900K. Yeah, the world record's literally on a 10900K. So, yeah, I'm guessing the 59, like, the thing is, this is not meant to be like a CPU benchmark. So it kind of makes sense that, well, and I still find it interesting that most of the top scores so far have been all done on like Intel CPUs, and it's only now that we see like a top 3 score with a 5950X. But yeah, 5950X on water cooling, quick disconnects for everything, which, man, like, that's a great, like, if you're going to be doing this kind of, chilled water cooling stuff, like, the quick disconnects are super convenient for this kind of setup, because you can just set up the ice bucket very temporarily, and then just connect the loop up, like, the parts of the loop that need to be connected to the ice bucket, and the parts that, because you don't want the main radiators connected to the ice bucket. They're actively, like, they're just going to be heating up the coolant. If you're like, if you have chilled coolant running through an ambient air radiator, it's going to be, heating up the coolant. So, yeah. So, cool setup. Just like, also, this looks like his daily system, which, that's brave. That's really brave. I wonder how he has those GPUs insulated, or if he's just winging it, where it's like, oh, I'm gonna run the benchmark in under X like minutes, so it won't destroy the system. Because yeah, you really don't want to be getting condensation in a, like, you don't want condensation buildup anywhere, anytime. Like, even on LN2, it's like, that's why we insulate everything. It's just like, we don't actually, like, you don't want the condensation screwing you over. So this is yeah, this is really brave. Unless he has the cards like conformal coated or plasti dipped or something, which we can't see from here. Or maybe this was like a really, really quick run, in which case, yeah, you can get away with it if you do it fast enough, right? Like, it's kind of the thing. But yeah, just awesome score, and awesome to see a unique setup. I mean, it's not that unique. We've seen ice buckets before, but this is, I guess, sort of like a nicer configuration of an ice bucket than what you normally see. And yeah, just solid score from Bavore here with the dual 3090s in 3D Mark Port Royal. So congratulations to him on that. Especially with just like doing, like, this really looks like his daily system. In which case, like, that's some commitment right there. I mean, I used to bench my daily for HWBot, but I didn't run ice water through it. So. Yeah, anyway, let's move on to the next score, which is Matt 26 LFC's Cinebench R15 with the Core i7 3770K. So top score for 3770Ks in Cinebench R15, doing 6.563 gigahertz. Is this on direct die, or is this on... Or does he still have the IHS? That's a shame that we don't know, because, yeah, anyway, if you're wondering how to deal with thermal paste cracking on CPUs, this is the most common way of trying to work around it, is just apply a ton of thermal paste. This does actually work. There's no such thing as too much thermal paste. Worst case scenario, you just end up with a, with a mess that you end up having to clean up, but... Yeah, like this is how you deal with CPUs where, they don't come soldered from the factory. This is what you need to do to run them on LN2 properly. And yeah, we've got 6.563 gigahertz on the 3770K at just under 1.9 volts. Memory running 2400 811 728, which is not exactly... Well, I don't know about the Ivy Bridge, but by like general DDR3 standards, this is not that ridiculously high. But then Ivy Bridge memory controllers, I don't know how those behave, and then also the LN2 might, change the behavior there. Running on an ASRock Z77 OC formula, which, yeah, I wish we had a system picture for this one, but a very, very solid score in a very competitive ranking. Like, again, the 3770K is just a super popular, extreme overclocking CPU. sort of like this, like 3770K, you know, like late DDR3 was kind of the peak of, I'd say, competitive overclocking setups, and then after like the after like Z87, that's when we started seeing all of the motherboards go gaming, right? And then eventually we got like X99. I feel like we started seeing RGB, and then we're seeing extreme overclocking motherboards come back now. But yeah, 3770K Cinebench R15, very competitive ranking. And Matt26 also got a bunch of other like strong scores with the 3770K, but this was his best one, so that's why this or this was his one of his best ones, so that's why I chose this one for the roundup. Um, and yeah, just cool to see Ivy Bridge chips getting, you know, pushed ever further. As the top score for Cinebench R15 with a 3770K has been steadily creeping upwards, right? And yeah, so congratulations to Matt on the, you know, top score with the 3770K. And let's move on to the next score, which is Kuby's 3D Mark Time Spy Extreme, which is on the GTX 1080 Ti. So this is a top score in Time Spy Extreme specifically for the GTX 1080 Ti. Literally first place, so great result right there. From Kuby's, running 2505 on the core, 1652 on the memory. I can't remember what kind of clocks 1080 Ti's are supposed to be hitting. So, well, actually, highest clocked out of anybody who's run this. Apparently, not many people have run Time Spy Extreme on LN2 yet, but even then, like getting 1080 Ti's, like up to around 2400, 1080 Ti's are pretty easy. And then past 2400, things get very difficult. So 2500 is a very solid frequency to be running on a 1080 Ti. What 1080 Ti are we looking at? Is this a Kingpin edition? I don't think so. That looks like it's got through-hole inductors. What card is this? Let's see. Asus. Strix? Oh, yeah, it might be a Strix 1080 Ti. So yeah, a very solid score. And that means, like, he's got to have vault mods. Or at least I think he should have vault mods. Because, yeah, wish we had a better picture of the card. But just a very solid score. 5950X running 4.7 gigahertz for the, you know, to get a nice CPU score right there. Memory doing 3733, 1414, 1422. Just kind of relaxed for what I would assume is a relatively memory intensive workload, because Time Spy Extreme CPU test should be, like, I think it's AVX accelerated. So, and a lot of things that are AVX accelerated generally tend to be somewhat memory limited. So yeah, but you know, still a very solid CPU score there. And then of course, like the other thing is this is Time Spy Extreme, and so if you're getting 11,000 points in the CPU test, like if your GPU is barely doing 6,000 points, then you know 11,000 points on the CPU test is more than enough points. GPU core temperature properly glitched out, which yeah, that just happens on liquid nitrogen. Makes it really hard to figure out if your thermal paste application has failed, because you don't have a temperature indicator unless you like stick a thermocouple to the back of the card. Yeah, so just a very solid overclock out of from Kuby's on that 1080 Ti, and he got first place in Time Spy Extreme with it, which I should run this benchmark on my 1080 Ti. Or one of my 1080 Ti's, or maybe two of them at the same time even. Yeah, so congratulations to Kuby's on taking first place for the 1080 Ti Time Spy Extreme ranking. And let's take a look at the next score, which is TAG's SuperPi 32 million on the Intel Core 2 Duo E6420, which took 9 minutes, 47 seconds, and 813 milliseconds. On liquid nitrogen, on not a Rampage Extreme, a P5E3 Premium from Asus motherboard, using the X48 chipset. So I guess this is like a Rampage Extreme Lite. I'm not actually don't actually think that that's don't assume that's actually true. I know nothing about LGA 775. Um, or well, I know it exists, and I know that it can take DDR3 and DDR2 and like a very wide range of CPUs. But anyway, in terms of memory settings, we're looking at 1860 676, so very low timings, but not that high frequency. And I like again, I don't know much about 775, so I'm gonna assume that this is just kind of as good as it gets. And then the CPU itself is only doing 5 gigahertz. Man, there's such a range of there's such a range of frequencies that like 775 runs. And I guess it just comes with the fact that there's just so many different CPUs that you can put into this platform. Oh, and also the CPU has an 8x core multiplier, so I guess it's just FSB limited. Like, yeah, like FSB limited at that point. Let's look at some of the other scores for this, because you know, if I don't know anything about the platform, we gotta do some comparisons. So yeah, Tag seemingly managed to just run the highest core frequency, also the best memory, like basically the best memory settings, like better memory second, or well, comparable memory settings to second place. This is on a Rampage Extreme. And then the scores below that just don't have the CPU frequency to compare. So yeah, very, very solid result from Tag, though I just like don't know enough about 775 to like explain what's going on here very well. But like that E60, like that's the fastest E6420 to ever run SuperPi 32 million, right? So that's something, I guess. Yeah, so impressive score. Managing to just outclock everyone on the E6420. And then Tag also ran a E4400 and like a bunch of other Core 2. I'm not even sure they were all Core 2 Duos, but they were a bunch of like bunch of LGA 775 chips, which you need to overclock with the FSB. So yeah, he ran a bunch of these and got a bunch of top scores for a variety of them. And I didn't feel like including 5 different chips from the 5 different scores, and I think they were all even SuperPi top scores. So evidently he just figured out one set of settings that work, and then it was just like chip after chip after chip, you know, taking records. Well, yeah, 4.8 gigahertz on the E4400. 10 times multiplier this time and much lower FSB. So I guess this chip is just like frequency limited there. Higher memory. Wait, is that higher? Yeah, slightly higher memory frequency. Still the same timings. And a longer run time because like SuperPi is a single-threaded CPU benchmark. It loves memory performance, but it doesn't like it's not so memory limited that you know you're gonna beat a score that's running a higher like that much of a higher frequency. There also might be some other. Actually, these are both Conroe. Do they have the same amount of L3? Because that's like we've got. Oh wait, these don't even have L3 cache. There's a difference also in how much L2 cache they have, which would affect a benchmark like SuperPi quite a lot. So, yeah. So yeah, Tag basically went and just got a bunch of these kinds of CPUs. Like I think I saw E4500, maybe like a bunch of them. Like just a bunch of them. Actually, I bet if we go to his wall, we'll just see. Assuming the wall is working right now. That's been a feature that, yeah, so E4400, another E4400, yeah, so a bunch of E4400 scores, a bunch of E4500 scores. It's not going to load more. Some Athlons. Where's the 6420? Anyway, yeah, so just a bunch of very solid scores on LGA 775. So congratulations to Tag on those. And let's move on to the next score, which is Salty Croissant's 3D Mark Vantage Performance, third place on the HD 4870X2. And he's running a Asus B550 Strix Strix B550E gaming motherboard with a 5900X. And the 5900X advantage is very significant because it allows you to get a very high CPU score. You do have to disable your SMT for that because Vantage is an old benchmark that has no idea what to do when it sees more than 16 threads. Well, up to a point. Like, I think 20 threads, like 10 core 20 threads is mostly okay, but if you have something that's like a 24 thread CPU or especially a 32 thread CPU, you have to disable the multi-threading because Vantage just sees that many threads and the CPU score tanks. So yeah, 12 cores, 12 threads on the 5900X here. Also, if you have a 10900K, you can just run it in 10 cores, 16 threads, which is a neat thing that 10900Ks can do. Yeah, 4870X2 on chilled water cooling, doing 967 megahertz on the core and 955 on the memory. Yeah, here we have the actual card with some. Is that supposed to be a heatsink? I mean, I guess it has more surface area than bare chips, but that right there does not. A unique cooling system for if I'm not mistaken, this card has a VRM right over here. Yeah, like this is man, dual core card. Like, I love dual core cards because of just how awkward they are in terms of just where do you put everything, right? Like, where do you put, like, there's some cards that instead of having two separate V-core VRMs, they'll have one V-core powering both cores, which not ideal in terms of, like, powering two different chips that are different distances apart away from the V-core VRM. Not ideal in terms of power delivery. Then you of course have the cards that just try to shove two have to. Well, a lot of cards will just have two of each voltage regulator, so literally two cards sharing a PCB at that point. But then you always run into the challenge of actually fitting that onto a card within a reasonable size. So that's how you end up with like a VRM hanging out over here. Then also you need the PL, like you need some kind of PCIe switch chip, which just makes the whole thing an even bigger. Just there's more stuff that needs to be on the PCB. It's not just like, oh, you just take two cores and put them on the like. It's not like you just put two cards worth of components together. There's more stuff you need than just that. Like the PCIe switch. And so, yeah, I'm just a huge fan of dual core cards because they're just like a horrible mess in terms of actually, like, compared to single core cards. This is just like, why would you build this? This is so awkward. But anyway, and then the cooling situation as a result of that ends up looking like this a lot of the time because, I mean, this card at least is using square mounting holes, but it's really, really close together mounting holes. I think this is one of the smallest mounting hole spacings that you can find on AMD GPUs. I think it's also used on like low-end AMD single core cards like 7770. I think the 5770 also uses it. And yeah, so, a lot of GPU water block, like a lot of universal GPU water blocks like these. Well, one of these is a supremacy block and the other looks like an eBay special. Yeah, with blocks like these, you're gonna end up in a situation where it's like these don't just they don't have the spacing for the mounting holes that are on the card, and you end up having to run zip ties like this. Yeah, like at least these are square. There's some cards out there, like especially GTX 590s, where the mounting holes are just kind of wherever NVIDIA found space for them, and the end result is they're not square at all. They're not even rectangular. Like, it's some irregular, four-sided shape, and it's just like, why? But anyway, so at least these are still square. So you can get pretty even mounting pressure even with zip ties as long as you line the blocks up properly. And also, since the holes are so close together, you don't run too much risk of like bending the PCB a bunch. there's less leverage on the PCB with the holes being closer to the actual chip. So yeah, and then here we have the actual setup, fan for cooling all of the components on the board that don't get cooled by the water cooling, and of course the VRMs, and then another fan over here, and then we have a lot of radiator, and just honestly, this is a rainbow puke covered mess. This setup right here. But hey, it produces good results, so that's all that really matters, right? Like this is a third place in 3D Mark Vantage for the 487TX2. And this is a pretty competitive ranking, right? Like we have a 487TX2 running on LN2. I'm guessing this had to be like I actually don't know. Like it could be VRM limited. It could be like it could be just 487TX2s don't scale on LN2 very much. Fortunately, I want to see the LN2 setup, because how did you get to? Don't show how they got two LN2 pots. Are you kidding me? I want to know how you got two LN2 pots on one of these. These really, like, is there like a voltage control limit? Because like Salty Croissant is running really close in terms of core frequency to a lot of these like LN2 scores. Oh, here we have one. Oh, oh no, there are GPU pots that just fit on these. They're not very big though. So this in terms of temperature control has to be a nightmare. Also, just pouring into them has like you can see it's just awkward to pour into LN2 pots like that. So yeah, I need to do something with my 487TX2s. And apparently they run on the B550 Asus boards, so that's great news for me because I have a B550 Asus board. I suspect that AMD CPUs are actually more compatible with old GPUs than like a lot of modern Intel chips. Like I've had a lot of modern Intel platforms where it's like you put an old GPU into it, and not even necessarily a dual core card, you put it into the CPU slot and it just doesn't post because it doesn't see the GPU. Yeah, but apparently 487TX2s work on B550, so yeah, I like, and I have two of these things, so I really need to get around to doing something with them, because this looks fun. This just looks fun. I'm not sure that I'm gonna commit to this kind of cooling method here, but I definitely need to do something with the ones I have. So yeah. Anyway, let's move on. So congratulations to Salty Croissant on that third place finish on the 487TX2 rankings. Let's move on to the next score, which is Wittix. Yes, he's back with another CPU frequency record, this time on an Intel Celeron E3300, doing just under 6.2 gigahertz on, of course, a Gigabyte GAEP45T UD3R motherboard. CPU's on liquid nitrogen, because of course it is, and CPU-Z is lying about the core voltage, because of course it is. But yeah, like Wittix has been just sort of taking CPU frequency top scores for a lot of old LGA 775 CPUs for a while now. I think most of his scores are featuring this motherboard right here. Yeah, apparently these Gigabyte P45 chipset motherboards are like really good at FSB, though it doesn't look like that's necessary here, so I'm not sure. Yeah, unfortunately, when I say I don't know much about I don't really know much of anything about LGA 775. But like when somebody takes a top score, like the website just kind of tells you this is the highest clocked Celeron E3300 ever. Yeah, that's a solid result from Wittix right there. So congratulations to him on I get, like, the thing is, for a lot of these also, you have to, it's not just about the motherboard and the cooling, it's also about, like, binning these CPUs, especially, like, with the reason why a lot of these old LGA 775 CPUs are so popular is because you can buy them by buckets. Like, you can literally just go and buy a bucket of LGA 775 chips, and then you get to go bin them, and, yeah, that makes a lot of these top frequency validations very difficult to do, because you need to go through potentially a lot of CPUs. And then, of course, well, I don't know how easy they are in terms of handling, but I'm assuming a lot of them have cold bugs. And then, you know, like you're doing FSB overclocking all the time. So, yeah, these are like very popular scores to do. At the same time, a lot of time and effort goes into them because, like, well, everybody has the same idea where it's like, oh, I'm gonna have the fastest ancient 775 CPU, and it's like, and then you end up with rankings where, like, what was the previous record? Well, the previous record was set in 2010, which I don't believe the E3300 was very relevant in 2010. Uh, so I'm assuming already back then there was quite a bit of binning going into these. And then the third place is also from 2010. Um, but yeah, so congratulations to Wittix on taking another like 11-year-old world, like 11-year-old CPU record, because he has taken quite a few of these like super old frequency validations. So yeah, congratulations to him on that. And let's move on to the next score, which is Moycot Libit Moloko, which I've found out means my cat likes milk a lot, I think, or just my cat likes milk. Well, he's back with another extremely ancient Intel CPU. This is a Celeron 800 megahertz. It's got one core. Yes, just one. And 128 kilobytes of cache. L2 cache. Not like level 1 and level 2 level 1 data and level 1 instructions is 16 kilobytes. So it's got like no cache, stock frequency of 800 megahertz. So almost doubling the operating frequency, right? He like went from under a gigahertz to around 1.5 gigahertz core clock, running SuperPi 32M on it for an hour and 8 minutes. Considering this is like, so SuperPi 32M, you know, single core benchmark, very memory sensitive. And the thing is, these days you can't really consider it a stress test because every CPU has more than one freaking core. But this thing has literally one core and it's been running like this is very stable, right? Like this had to run for an hour and 8 minutes. On phase change, single stage phase change. C-clamp mount for attaching the phase change to the motherboard. Yeah, here's the system. Back in the day, motherboards were yellow, not green, surprisingly enough. Like I would have thought like a lot of the old motherboards would just be green, but apparently a lot of them are this really off yellow color. I guess it does make the traces a bit easier to see than having them be green. So anyway, but apparently running on value RAM. Well, it is literally a green memory stick. And I guess it's single channel. Of course it's single channel. Why would dual channel wasn't a thing back then? SD-RAM, 512, like half a gig of RAM, running 190 megahertz. And SD-RAM, so this is single data rate, I'm pretty sure. So this isn't double data rate. This is single data rate. This is the actual like you don't have that weird thing where like people say megahertz when they mean mega transfers. No. This is megahertz and mega transfers at the same time. Running 2227 timings. Like that sounds really low until you consider that each of those like because timings are measured in clock cycles and these clock cycles are very slow. But yeah, like this is like some serious commit. Like running a benchmark for an hour and 8 minutes is just like not something I would do very like for fun. That's not my idea of a fun time, especially something like SuperPi where it's like you really need to be very certain that this is going to be pretty stable or extremely committed. Right? Like how many I guess this is one of the benchmarks where it might be worth it to like I have no idea. Like how do you there has to be some way to not like, you know, wait for the benchmark to finish for an hour and then have it crash right before the end. But I can't really think of any way you could do that. I guess you could maybe try run something heavier than SuperPi for a short period of time before running SuperPi, but I'm not sure that like this is a single core CPU. Like it's not I'm not sure that's really a thing, right? Also just look at how many different instruction sets it supports, which is like 2. So, yeah, I can't imagine like I guess you just kind of got to go for it and hope that it survives, the entire run. So, yeah, congratulations to Moycot Libit Moloko on the Super Pi 32M top score for the Intel Celeron 800 megahertz CPU. Like 1 hour long, but like this isn't the first time I've featured him for one of these insanely long Super Pi 32M runs on CPUs where it's like, to me, this is like I call LGA 775 ancient, but this is proper ancient as far as I'm concerned. 775 is me being like exaggerating. It's not that old. Like like LGA 775 is just barely outside of what I'd be willing to like get into. Like I have X58, I have a bunch of AM3 and AM3 plus, and so like I like basically I'm willing to go down to like mid DDR3 era and up. But this right here, this is before DDR2. This is before DDR. This is, yeah, proper ancient technology right here, and extremely slow. Which I guess just makes like that turns a lot of the old benchmarks into just straight up stress tests at that point, where it's like, well, yeah, like it's got to be damn stable if you'll run SuperPi 32M for an hour and 8 minutes. So, yeah, congratulations to him on the score. And let's move on to the last score, which is Martin White's GPU Pi for CPU 100 million on the Core i3 4160. Yes, a locked i3 CPU, running on water cooling, 58 degrees load because it's an i3, 2 cores, 4 threads, on a MSI Z87 M Power. And you know what? I gotta say, like, this heatsink design that MSI had on that motherboard, pretty neat. The VRM on there is not so neat. Like, that VRM right there is from the peak of the phase count wars between the manufacturers. And though they are arguably called the phase count wars, nobody had real phases. Or more like, real phases were extremely rare. Like, this VRM, if I'm not mistaken, off the top of my head, this was a like 5-phase running into a bunch of doublers, and then it was actually 10 phases, but with like 20 phases worth of components. It might have been it might have been using 3598s. So maybe it wasn't quite that bad. Maybe it actually was 20 phases. It's been a while. I need to see if I can dig up any pictures of that motherboard. I had one of these. This was one of my I had one of these. Got rid of it because it wasn't particularly great at memory overclocking. But that didn't stop Martin White here from pushing his DDR3 to, well, that's the thing. 2280 at 7:10.7, and the timings are good, but for Haswell, this I'm assuming is some kind of PSC memory. Yeah, like these are G-Skill Pis. I'm gonna assume this is PSC. Oh, we don't have a we don't have a SPD readout, so that's a bit of a shame. The thing is, on like Haswell platforms, you would generally be aiming for like 2600 CL8. At 1T command rate, and if I remember my experiences with the Z87 M Power correctly, the 2600 CL8 part was easy. The 1T command rate wasn't. I might be misremembering that. It's been a really long time since I had that board, but still, i3 4160 with a pretty some amount of BCLK overclocking, right? The awkward thing with BCLK overclocking is it just tends to destabilize absolutely everything, because on basically from Sandy Bridge to Haswell, Sandy Bridge to like Haswell E, I guess. If you tried to overclock the BCLK, it overclocked everything. It overclocked your PCIe. It overclocked your SATA. It overclocked like everything. And the problem with that is that everything would get like your CPU wouldn't necessarily have a problem with the higher VCLK, but everything else in the system very easily could. So getting like high VCLK overclocks to work properly was just very, very difficult. But yeah, a very, very solid score here with 41 seconds to complete 100 million digits of pi. This is a multi-threaded test, and he took first place for the Core i3 4160. So yeah, actually beating multiple scores that were clocked significantly higher. So I'm guessing that's just down to memory setting. Let's take a look. Right, and this is what is like. If you hear somebody talking about like efficiency with scores, that's what's referred to as like how much CPU frequency you need to get a certain score. If you can get a higher score at like if you can beat some like if you need less CPU clock to get a certain score, you have good efficiency in a CPU benchmark, right? And normally the way you get good CPU, like good efficiency is like there's the various OS optimizations that you can do, and those depend on the benchmark. Like, well, there's some general ones you can do, like not having an OS full of garbage. But then there's also some like super benchmark specific ones that, like SuperPi is a great example of a bunch of those, and we're not going to get into them because I don't even know all of them. Then like and then also you have like the whole running the appropriate OS for the benchmark, and what else is there? Well, so so you have like the OS software type stuff to get better scores, and then you have just like in a CPU benchmark like this, assuming that it's sensitive to memory settings, well, you can just beat your opponents on by having better memory settings, right? Because the CPU like if your benchmark is starved for memory bandwidth or latency or whatever, or a mix of both, you can just get more performance by getting data to the CPU faster so that the CPU can actually process it. Anyway, let's take a look at what the other scores are like. So this is actually running worse memory settings, yeah, because that's similar frequency. Maybe the old i3s had a worse memory controller than most of the other Haswell chips. Like, that is a possibility. I don't know my i3 4160s. That's Martin's. Then we have this score over here, which also very similar memory settings. So I wonder if maybe they had maybe they had a restriction on the max multiplier? What's 107 times? No, that's got to be on like 2133 or something. So I guess these have a different memory controller from the... But the G3258 does perfectly good memory clock, so I have no idea what is going on with that. It might be just like maybe GPU Pi doesn't care for frequency that much. It's not really a benchmark that I run very often. Actually, yeah, I don't think I've ever run GPU Pi for CPU. Now that I think of it, it's not really one of those benchmarks that I'm. Yeah. Anyway, but yeah, so Martin here. I mean, better memory settings, great efficiency in the benchmark because he is running quite a lot lower core frequency than the next two scores down, and getting the first place for the Core i3 4160 rankings. In GPU Pi for CPU 100 million. And, I try to include a locked CPU top score, so that's why we're looking at this one. So, yeah, that is it for this week's HardwareBot score roundup. We've got way too many scores. Damn, I need to stop just including every score that I'm like, well, it's a cool score. And there was like many other cool scores this week. Like this week was really intense on the top scores, but yeah, evidently I think I spent too much time talking about Y-Cruncher. But the thing, we need more people running Y-Cruncher. It's awesome. I guess we also need more people on X299, but X299 is kind of it's a really awkward platform. Like if you need cores, it's just like, yeah, it's a really awkward platform, isn't it? It's really good at Y-Cruncher, though. Need more people running that. So anyway, I don't really feel like reshooting this one, so we'll just leave it at an hour and almost 20 minutes. Actually, maybe by the time I hit the stop button, it'll be 20 minutes. So yeah, thank you for watching, and like, share, subscribe, leave any comments, questions, suggestions down in the comments section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There is a link to that down in the description below. There's also the AHOC Teespring store, where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. It would be much appreciated if you check out the Patreon and Teespring links, because they help out immensely with running the channel. And yeah, that is it for this week's HWBot score roundup. So thank you for watching, and goodbye.